Having a language that is written in numbers and symbols has been an idea that has lasted for so long. Many new concepts have been added, which have made the use of numbers as a language richer and more user-friendly. In this video, we are going to introduce ourselves to this kind of language. We've called it indices. Now, where exactly do indices come from? Indices actually arise from the multiplication of similar factors of a given number a number of times. For example, right in front of your screen, we have 2 times 2 times 2. If you look at that, 2 has been multiplied 3 times. That's why we are calling it 2 to the power 3. Here we have 2 times 2, then we have 3 times 3 times 3. 2 times 2 has been multiplied 2 times, that's why it is 2 to the power 3. Then 3 has been multiplied 3 times, that's why we are calling it 3 to the power 3. The power represents how many times the number has been multiplied. When you look at 2 to the power 3 or 3 to the power 2, this is the general term, x to the power n, and we are saying that this bottom number is the base and the power is what we are calling the index, and the index or the power, that's why we call them index numbers. It therefore follows that for 2 to the power 3, 2 is the base, 3 is the power. Right, same with this, 3 to the power 3, 3 is the base, and that 3 up there is the power or the index. So we are going to proceed to look at the laws that govern indices. These are the very laws we use when we are calculating and manipulating numbers that involve indices. Right here we have, in general terms, if we are having a to the power p times a to the power q, if the bases are the same, then you simply call it one base and you add the powers. So it's going to be p plus q. For example, you're having 2 to the power 4 times 2 to the power 3. The bases are the same, it is 2. So you simply maintain the base and you add the powers, 4 plus 3, giving us 2 to the power 7. This is when you're multiplying indices. If it is division of indices, it is we are dividing indices of the same base, we maintain that base and we subtract the powers. In this case, it will be m minus n. Then we have a to the power p, all this is in brackets q. This is the same as saying, it's the same as multiplying these powers up, p times q. Just like in our example here, this is 8 squared, but this whole index is again to another power 4. It's the same as multiplying these 2 by that 4, and 2 times 4 is 8, so it's 8 to the power 8. That's the answer to that. And then we have a to the power negative p. Now that negative it serves to represent the inverse, or the inverse of this, or the reciprocal of a. So a to the power negative p, to be able to remove that p means that you put this a in the denominator, so it's going to be 1 over a to the power p. For example, 2 to the power negative 5 gives us 1 over 2 to the power 5, which is 1 over 32. Or you can, this is the same as saying 1 over 2, and this whole thing is to the power 5. It's the same. This is the reverse of what we did before. 1 to the power negative p, to remove that negative means you're going to find the reciprocal of a, and the reciprocal of a means a gets to the numerator and this one gets to the denominator, which is a to the power p. So in our example here, 1 to the over 8 to the power negative 1 is the same as 8 to the power 1. It's the reciprocal of that number that gives you the number to the power that digit without the negative sign. Then we have a over b to the power negative p. Again, if you want to remove that negative sign, you simply find the reciprocal of this. And so of course the reciprocal of a over b is b over a to the power p without the negative. And in our example, it is well illustrated that 2 over 3 to the power negative 2, to remove that negative sign, you get the reciprocal of this. So it's going to be 3 over 2 to the power 2 without the negative. Then there's another identity here that a to the power 0 is 1. Whether it's 1,000 to the power 0, or 1,000,000 to the power 0, or 20 to the power 0, any number to the power 0 is 1. 100 to the power 0 is 1. Now, when we are dealing with numbers, when we are dealing with index numbers, it is important that we have these laws that govern indices on our fingertips. Because when we are interpreting numbers such as these, it is these very laws that we are going to use to interpret them. It's important that you memorize them so that they are at your fingertips. We are being required here to simplify 2 to the power 3 times 2 to the power 4 times 2 to the power negative a half. And if you look at this number, we are having multiplication of these index numbers, but the base is the same. And since the base is the same, so it means we are going to maintain it. So it means it's going to be 2 to the power. In multiplication, when the base is the same, we add the power. So it's going to be to the power 3 plus 4 plus negative a half. And our answer is going to be 2 to the power 13 over 2. Right here, still the same 5 times 5 times 5. This index, it's multiplication of indices, so we maintain the base since it's the same. So it's going to become 5 to the power, you add the powers. So it's going to be 4 plus 3 plus negative 1. And definitely this is going to become 5 to the power 4 plus 3, 7. 7, this becomes minus. 7 minus 1 is 6, so it's 5 to the power 6. We have another here, it is 3 to the power 5 times 3 to the power 6 divided by 9. Now, when we're dealing with index numbers and we identify that it is being mixed up with a number that is not an index number, for example here 9 is not represented in form of an index number, you try and first convert it into an index number so that it looks like the rest of the numbers. Then you can go ahead and simplify it. For example, 9 can be represented as 3 squared. So it means that this becomes 3 to the power 5 times 3 to the power 6. Divide that by 3 to the power 3. Because 3 to the power 2. This 3 times 3 is 9. So this here it's multiplication, then here it's division. So it means what we do here, since the base is the same, we are going to maintain the base. And with this multiplication, we first add. It's going to become 5 plus 6. So here it is 3 by 3. So we add the powers because it's multiplication of indices, which is 5 plus 6. Divide that by 3 to the power 2. So this becomes 3 to the power 11 divided by 3 to the power 2. Now division, with division here, when the bases are the same and it's division of these indices, we subtract the powers. So definitely here it's going to be equal to 3 to the power 11 minus 2, and this is going to become 3 to the power 9. In our previous video, we introduced indices, and we said that just like that, if the value of, we are having a general term x to the power 4 or x to the power 3, this x is the base and these 4 and 3 are indices. So in other words, as for now, 4 and 3 are the indices. Now today we get to look at what we call fractional indices. Now a fractional index is what we shall refer to as a rational index. Right here, x to the power 4, these 4 and 3 here are indices. But then now the fractional indices is just when these 4 and 3 are taken over by fractions. Like you may see here, that x to the power 2 over 3 and x to the power 4 over 3, the 2 over 3 and the 4 over 3 are what we are calling rational or fractional indices. And the rules or the laws that govern how you interpret the rational indices, how you multiply them, how you divide them, are more or less the same as the rules that we explored in our previous video when we were looking at how to multiply and divide indices. For example, when we are multiplying fractional indices, x to the power p over q and x to the power n over q, when the base is the same, you're going to add the fractions. So which is p over q plus n over m. And in our example, it is well spelled out that a to the power 3 over 4 times a to the power 2 over 3. Because it is multiplication of these two indices, they are having the same base, so we shall add the powers. And so it's going to be a to the power 3 over 4 plus 2 over 4. When we add that to fraction, those two fractions, we end up with a to the power 5 over 4. When we are dividing, it's just like before. When we are dividing indices, if they are having the same base, we subtract the powers. So right here, it's p over q over n over m. In our example, it is a over 2 over 3 divided by a to the power 4 over 3. Because the a is the same base, we shall maintain the base, but what shall we do to the powers? We shall subtract them, which is 2 over 3 minus 4 over 3, and our answer will be a to the power negative 2 over 3. Again, when we are having p over q to the a to the power p over q, this is the fractional index. All this is still to the power n over m. It's the same as saying this times that. So in our example, it is a to the power 4 over 5 times, and all this whole thing is still to the power 2 over 3. So it is this fraction multiplied by that fraction. It is still the same as saying a to the power 8 over 15. A to the power negative p over q is going to be equal to, now for us to remove this negative, we have to find the reciprocal of a. And definitely the reciprocal of a is 1 over a to the power p over q without the negative. And this is well illustrated in our example, that x to the power negative 2 over 3, for us to remove that negative, this is the same as 1 over x, which is the reciprocal of this, 1 over x to the power 2 over 3 without the negative. Or it is the same as 1 over x, everything to the power 2 over 3. Then if it is a over b to the power negative p over q, to remove this negative again, we get the reciprocal of this fraction. So it's going to be b over a to the power p over q without the negative. Just like here, 2/3 to the power negative 4 over 5, to get rid of that negative, we get the reciprocal of this, which is 3 over 2 to the power 4 over 5 without the negative. Now, we are going to be using these laws in solving numbers, or in solving these fractional indices in our upcoming videos. Thanks for tuning in. Stay tuned for more of these videos. Still under index numbers, there is a concept we call the roots. And the roots, you can have the square root, the third root, the fourth root, and so forth. Now, today we are going to look at how to compute these roots. How we are able to identify that this is the third root, this is the fourth root, and so forth when we are given numbers with fractional indices. This is Kisembo Academy, and thanks for tuning in. So right on our screen we have something called, this is a fractional index, a to the power m over n. Now, there is another interpretation of this. A to the power m over n is the same as a to the power 1 over n into m. And this is the same as the root of n to the power m. In other words, if you look at this, 1 over n, this is m over n. Now this is the same as 1 over n times m is actually m over n, which brings us back to this. It's like when they give you 2/3. 2/3 is the same as saying you 1 over 3 times 2. You displace these 2 out and you make this 1 over 3 times 2. So 1 over 3 times 2 is the same as 2/3. Or if they told you 6 over 5, 6 over 5 is the same as saying 1 over 5 times 6. So our interest here is to create a fraction that is having 1 as the numerator. And that's what we are doing here. That m over n is the same as 1 over n times m. We are interested in this fraction that is having the 1. Because any number to the power 1 over n is equivalent to the root of that number n. For example, if we are saying that if it is a number, let's call it 2 to the power a half. This is the same as the square root of 2. If it is 3 to the power quarter, this is the same as the fourth root of 3. If it is 6 to the power 1 over 5, it means it is equivalent to as the fifth root of 6. That is what this means, 1 over n. So here we have a to the power the root of n. N can be any number, of course not 0. Then all this is to the power m, and this is the interpretation of that. Let's calculate a few examples. We have 25 to the power half. Of course 25 to the power half is the same as saying the square root of 25, and we all know that the square root of 25 is 5. Even here 100 to the power half is the same as saying 100, square root of 100, and we all know that the square root of 100 is 10. Now how can we calculate these things without having to use a calculator? The square root of a number, we'll have to prime factorize. I'm showing you an alternative method of solving this without using a calculator. If you look at 25 by 5, 5. So meaning that since they are telling us it's the square root, so you shall group these factors in groups of 2's, and from each group we shall pick 1. So here we shall pick 1 as 5. So that's the answer. Likewise here, the square root of 100, we can calculate it with, so this is by 5, we have 20. By 5 we have 4. 4 by 2, you have 2 divided by 4, you have 2. So after factorizing them like this, since it is square root, you group them in groups of 2's, that one and that in 2's. Then from each group you pick one number. Since these are groups of 5, you pick one number 5. Even here you pick 1, 2. So the answer here is 5 times 2, which is going to be 10. And 10 is the same as that. So that's how you calculate for the square root of a number. 27 to the power a third means it's going to be the third root of 27. The third root of 27. So how do you get the third root of 27? You can either punch it in your calculator and you get your answer direct, or you can get it by calculating. Now 27 here, you've prime factorized by 3, you have 9. By 3, you have 3. And since you're looking for the third root of 27, it means you're going to group these numbers in groups of 3's. And in each group you pick one number. So here we shall pick one number, which is 3. So meaning the third root of 27 is 3. Same as this, the third root of 125, this 125 divided by 1 over 3 is the same as the third root of 125. What's the answer? Let's look for the answer. So 125 by 5, we have 25. By 5, we have 5. So you group these, since it's third root, you group them in groups of 3's, the factors. And after grouping them in groups of 3's, from each group you pick one. So here we only identified one group, we pick one, and definitely the answer here is 5. So the answer, the third root of 1 to 5 is 5. 16 to the power quarter, same story. This means it's going to be the fourth root of 16. So the fourth root of 16, getting it is by 2, we have 8. By 2, we have 4. By 2, we have 2. So since we're looking for the fourth root, we group these factors in groups of 4's. So we have 1, 2, 3, 4. So we group these 2's all in groups of 4's. And when you group them in groups of 4's, we pick one number from each of those groups. Here we only have one group, so we pick one number. And when we pick one number, it is 2. So it means the answer here is 2. Same here, the fourth root of 625. Now the fourth root of 625 is going to be equal to, so we attempt to find it. We factorize 625. We begin by 5. We have 1 to 5. By 5, we have 25. By 5, we have 5. So we group all these in groups of 4's, since we are looking for the fourth root. And from each group of 1, 2, 3, 4, we pick one number. So all these are 5, so we pick 1, 5. And when we pick 1, 5, definitely now this becomes 5 as the answer. So we are required here to find the value of 81 to the power negative 3 over 4. So in a number like this one, we are supposed to first of all remove that negative index. And we say that remove that negative index, it means we are going to find the reciprocal of 81. So the reciprocal 81 to the power negative 3 over 4 is equal to 1 over 81. That's the reciprocal. But all this is to the power 3 over 4. So it goes ahead, it follows that 3 over 4 is the same as, just like I had explained at the beginning of this video, that 1 over 81 is going to be to the power a quarter, and all this is to the power 3. Because 3 times a quarter is supposed to give us 3 quarters. So now it means that here we're supposed to find the fourth root of 1 over 81. And of course, the fourth root of 1 over 81, the fourth for 1, it is going to remain as 1, divided by the fourth root of 81. Let's do some side work here. The fourth root of 81, if you look at 81 by 3, you get 27. By 3, it is 9. By 3, it is 3. And since we are looking for the fourth root, you group all these in groups of 4s. You choose 1, so definitely the fourth root of 81 here is 3. So it's going to remain a third. So the fourth root of is a third to the power 3. And definitely this is going to become, to the power 3 is a third times a third times a third, giving us 1 over 27. Now, of course, solving this kind of number, this is equivalent to, we are supposed to first find the fourth root of 16 and the fourth root of 625. So this is going to become the fourth root of 16, 2 over 5, and this is going to be to the power negative 3. So this is the same as, to remove that negative, you get the reciprocal of that number. So it's going to be 5 over 2, all this is to the power 3. And our answer is going to become 5 over 2 times 5 over 2 times 5 over 2. You end up with 125 over 8. In this video, I'll be doing more worked examples on indices. Thanks for tuning in. This is Kisembo Academy. We have 9 to the power half. 9 to the power half, like we had introduced in our previous video, it's the same as the square root of 9. So the square root of 9, what is it? Let's try and find it. If you look at 9, if I prime factorize it by 3, you have 3. Since it is square root, you group these in groups of 2, and when you group them in groups of 2, you just choose one number from the group 3, and therefore the answer here is 3. Let's get on to this. This 64 to the power 5 over 6 is the same as 64 to the power, it is 1 over 6, and this is to the power 5, because it is 5 times a sixth. 5 times 1 over 6 is 5 over 6. So you first deal with this. 64 to the power 6th. What is the 6th root of this? Because this is the same as saying this is the 6th root of 64, and all this is to the power 5. So what's the 6th root of 64? Again, to get, you can use your calculator to get it directly, or we factorize it out. Prime factorize. So if you look at 64 by 2, if you divide 64 divided by 2, we'll get 32. By 2 we shall get 16. By 2 we shall get 8. By 2 we get 4. By 2 we shall get 2. And now, since we are looking for the 6th root, it means we are going to group these numbers, the factors, into groups of 6. 1, 2, 3, 4, 5, 6. So if this is a one group of 6, you choose one number from that group, and it is 2, 1. So it means that the 6th root of 64 is 2. So it's going to be 2 and to the power 5. So the answer is 2 to the power 5. You can go ahead and simplify it further. And of course, if you say 2 to the power 5 will give you 32. So you could as well just say it is 32. That's our answer. So looking at this here, we are having 49 to the power 3 over 2 times 49 to the power negative 7. Now these are two indices we are multiplying. They are having the same base which is 49. So what we do to the powers, we simply add the powers. So this is going to become 49 to the power 3 over 2 plus negative 7, which is, we shall say, plus negative 7. Divide all that by, now we have 64 to the power 3 over 2 times 8 to the power a half. Now the bases here are different. How can we attempt to make these two bases the same? Now if you look at 64, if you factorize 64, I'll do some side work here. If you look at 64, if you divide it by 8, you get 8. It means that 8 times 8 is 64. 8 squared is the same as 64. So it means that to make it look like this, to make these bases look the same, this is the same as saying 64 is 8 squared. So this is 64. 8 squared to the power 3 over 2 times 8 to the power half. So you shall end up with 49 to the power, this is going to give you, now 3 over 2 plus minus 7, this is the same as 3 over 2 minus 7, and this is going to give us 49 to the power negative 11 over 2. Divide all that by, now of course here 8 to the this squared, 2 times 3 over 2, this 2 and that 2 will cancel, you remain with 8 to the power 3 times 8 to the power a half. So this is going to become 49 to the power negative 11 over 2. Divide all that by, this is the now become the same base, so it's 8, and then you add the powers. 3 plus a half is going to give you 7 over 2. And of course, this 49 is the same as trying to say it is 49 to the power a half, multiply that by 11 times negative 11, because negative 11 times a half is going to give you this. Negative 11 times a half gives you negative 11 over 2. So it's 49 to the power a half, divide by 8, and definitely that is to the power a half times 7. Because 7 times a half, when you multiply these powers, it's supposed to give you this back, 7 over 2. So this gives us 49 to the power half, the square root of 49 is 7. So it's going to be 7 to the power negative 11. Divide all that by the square root of 8. The square root of 8, which is approximately 2.83. And all this is to the power 7. This is going to become 7 to the power negative 11 is the same as, to remove this negative, you find the reciprocal of 7, which is going to be 1 over 7 to the power 11. Divide that by 2.83, and all this is to the power 7. And the answer you will get there will be from prime factorization, you know that 27 by 3 is 9, by 3 is 3. So it means that 27 is the same as 3 to the power 3. So this 27, you say it is 3 to the power 3. That's the 27 to the power negative a third. Multiply that by 1 to 5 to the power third. Now if you factorize 1 to 5, you know that by 5 you have 25. By 5 it's 5. So it means 125 is the same as 5 to the power 3. So this 1 to 5 is replaced by 5 to the power 3, and all this is to the power third. Multiply that by 32. So likewise we factorize 32. If you look at 32 by 2, will give you 16. By 2 will give you 8. Divide by 2 will give you 4. By 2 it will give you 2. And if you count this 32, it's 1, 2, 3, 4, 5. So it means that 32 is the same as 2 multiplied it by 5 times. So 2 to the power 5. So this 32 becomes 2. All this is to the power, this 2 to the power 5 to the power 1 over 5. After simplifying your figures in this kind of way through factorization, it becomes easier to deal with them. You know that this powers is 3 times negative a third. Here I remain with 3 to the power negative 1. Multiply that by, this is 3 times a third, the powers. When you multiply the powers according to our laws of indices, you remain here with 5 to the power 1 times 5 times that is going to give us 2 to the power 1. And definitely this being a negative 1, to remove this negative, you make this number a reciprocal, so it's going to become a third times 5 times 2, which is 10. So the answer here is 10 over 3. Please take note of what we did in our previous video. A to the power m over n is the same as a to the power 1 over n into m. And this is the same as the root of n to the power m. In other words, if you look at this, 1 over n, this is m over n. Now this is the same as 1 over n times m is actually m over n, which brings us back to this. It's like when they give you 2/3. 2/3 is the same as saying you 1 over 3 times 2. You displace this 2 out and you make this 1 over 3 times 2. So 1 over 3 times 2 is the same as 2/3. Or if they told you 6 over 5, 6 over 5 is the same as saying 1 over 5 times 6. So our interest here is to create a fraction that is having 1 as the numerator. And that's what we are doing here. That m over n is the same as 1 over n times m. We are interested in this fraction that is having the 1. Because any number to the power 1 over n is equivalent to the root of that number n. For example, if we are saying that if it is a number, let's call it 2 to the power a half, this is the same as the square root of 2. If it is 3 to the power quarter, this is the same as the fourth root of 3. If it is 6 to the power 1 over 5, it means it is equivalent to as the fifth root of 6. That is what this means, 1 over n. So here we have a to the power the root of n. N can be any number, of course not 0. Then all this is to the power m. And this is the interpretation of that. From that previous clip from our previous video, we said we can convert this back to the fractional indices. So it means this is going to become 2. Since it is the third root, so it's going to be 2 to the power a third. And this whole thing is times negative to the power negative 2. Multiply that by a root of 6, which is, it means this is 8 to the power 1 over 6. And this whole thing is multiplied by negative 1 times negative 1. All this is divided by root of 32. Now, the third root of 32 means it's 32 to the power 1 over 3. And that is multiplied by the negative 1. Multiply that by 2 to the power negative 1. This is the square root. So the square root of 2 to the power negative 1, it means it's the same as 2 to the power a half. Multiply all this by the square negative 1. Then multiply that by, this is the same as third root of 16 means it is 16 to the power 1 over 3. And all this multiplied by negative 1. Like that. So we proceed. So our next thing here is going to become 2 to the power a third times negative 2. This is going to become a third times negative 2 is going to give us 2 to the power. This times that is negative 2 over 3. Multiply that by a sixth times negative 1 is going to give us 8 to the power negative 1 over 6. Then divide all this by, this is 32 to the power negative a third. Multiply that by a half times negative 1, which is 2 to the power negative a half. Then a third times negative 1 gives us 16 to the power negative 1 over 3. So let's try and look and make these indices try and look the same. As you can see, we are all having even numbers all through. So this is already 2 to the power something. So can we make this one also 2 so that the bases are the same and we simplify the powers? Likewise down here. So we are going to take that approach. So it means that we are going to take on 8. When you factorize 8, we know that 8 by 2 it is 4, by 2 it is 2. So 8 is the same as 2 to the power 3. Then if you look at 32, 32 is by 2 is 16, by 2 is 8. Divide that by 2, you get 4, by 2 you get 2. So 32 is 1, 2, 3, 4, 5. 32 is the same as 2 to the power 5. If you look at 16, same story. By 2 you get 2, you get 8. By 2 you get 4, by 2 you get 2. So 16 is the same as 2 to the power 4. So we are going to replace these numbers with these. So it means if you look at this, this is going to become 2 to the power negative 2 thirds. Multiply that by 8 to the power negative 16. Now this 8 is being converted to 2 to the power 3. So it is going to be 2 to the power 3. Multiply that by negative 1 over 6. Divide all that by 32. Now the 32 has become 2 to the power 5. So it's going to become 2 to the power 5. All this is to the power negative a third. Multiply that by 2 to the power negative a half. Multiply that by 16. 16 has become 2 to the power 4. So it's times 2 to the power 4. All this is multiplied to the power negative a third. So our next step is going to become 2 to the power negative 2 thirds. Multiply that by 2 to the power. Now this is 3 times negative 1 over 6. 3 times negative 1 over 6 is going to give us 1 negative 1 over 2. All that is divided by 2 to the power 2 to the power 5 times negative 1 over 3 is the same as negative 5 over 3. Multiply that by 2 to the power negative a half. Multiply that by 2 to the power, this is 4 times negative a third. 4 times negative a third gives us negative 4 over 3. So our next step here now, since the bases have now been made the same, 2, 2, so we maintain the base and add the power since it's multiplication using the laws of indices. So that is going to become 2 to the power negative 3 or negative 2 over 3 plus negative a half. Divide that by, the bases are the same and it's multiplication, so it is, we maintain the base and we add all the powers. So when we add all the powers, this is becoming negative 5 over 3 plus negative a half plus negative 4 over 3. And definitely this is going to become, when you add these fractions, negative 3 over 2 plus negative a half is going to give you this is 2 to the power negative 7 over 6. Divide all that by, this is 2 to the power negative 7 over 2. Now if you look at this, This is 2 to the power negative 7 over 6, and this is 2 to the power negative 7 over 2. This is division of indices. You're dividing two indices that are having the same base. So it means that we're going to go ahead and maintain the same base and subtract these powers. So that becomes maintaining the same base to the power, subtract the powers, negative 7 over 6 minus negative 7 over 2. Of course, this is going to become 2 to the power negative 7 over 6. This minus becomes a positive plus 7 over 2. And our answer here is going to become 2 to the power 7 over 3. As simple as that. This brings us to the end of this video. Thanks for tuning in. For more of these videos, I encourage you to subscribe to this channel. Otherwise, don't forget to hit that like button. Coming up next is more of these. Stay tuned. For Kisembo Academy, this is Anodranga Kuramya.